In this video, we're going to be discussing similar polygons. First and foremost, let's not confuse the word similar with congruent. In similar polygons, what you have is the same shape, different size. Okay, so different size is the key piece. Similar is same shape, different size. Whereas congruent is same shape, same size. So notice this little cylinder here seems to be about half the size of this. And this hexagon here seems to be considerably smaller than the bigger one. But they're both hexagons and their angles, right? Angles will be congruent. But the sides are in proportion, right? And we'll talk more about this. So getting into your notes, polygons with the same shape, but different sides, right? Different size. Polygons are similar if two things are happening. First, as I said in the front, that the angles, right? The corresponding angles, the top left angle and the top right angles match up. They are congruent. They're identical. And number two, the corresponding sides are proportional, right? And we just spent a bunch of time discussing ratios and proportionality. So the ratio of corresponding sides is called, we've heard this word before, the scale factor, just like in dilations. So again, the scale factor describes how that proportion or that ratio is expressed. And also, if the polygons are similar, then their perimeters are also proportional. So the scale factor describes their perimeters, and it also describes their sides proportionality. Press pause and get this into your notes and make sure that you have a good understanding of what I just said. So now what do we do? We're going to have to identify the scale factor and sometimes apply the scale factor. And the scale factor, order matters, right? Order matters. If we're going from triangle ABC to triangle DEF, as we list this ratio, the first value has to correspond to triangle ABC, and the second value has to correspond to DEF. So what do? Pick any side over here. So 8 is going to be my first number, and that goes from A to B, from the single to the double. So I look over here, from the single to the double, that corresponds to 12. Now we want to express that in reduced form, so we divide these both by 4, and we'll get a scale factor of 2 to 3. So that's our scale factor from ABC to DEF. Now it says, what's the scale factor from DEF to ABC? It's the same values, but the order changes because now I'm going from DEF, the bigger triangle, to ABC. Now, what is the ratio of the perimeters of DEF to ABC? Right? The ratio, or the scale factor of the sides, is the same scale factor of the perimeter. That's what we just said in the previous page. So the previous answer then just comes down. So this is going to be 3 to 2. And why? Because we're still going from DEF to ABC. Pretty straightforward. Now the big thing is when you do this, that order matters. And over here, right, take care to make sure that you have corresponding sides, right? That's what I did to begin with. I made sure that I was matching up the correct sides. You don't want to go matching up 10 to 21. And then we're going to have a corresponding or a similarity statement. And we'll need to work on a symbol for similar. So this was the symbol for congruent. So we also have a similarity symbol, which is just a single tilde. So down here, we'll just say that triangle ABC is similar to triangle DEF. And how do we know? We know that because 8 over 12 is the same as 10 to 15, is the same as 14 to 21. These all reduce to 2 over 3. 14 over 21, both divide by 7, that's 2 over 3. 10 over 15, both divide by 5, that's 2 over 3. 8 over 12, both divide by 4, that's 2 over 3. So because all of the sides, right, all sides are proportional, right, the same proportion, right, all sides are the same proportion, then I can say that the polygons themselves are similar. And again, all of the angles, we know, match up identically. So the angles are identical, but the sizes of the shapes are different. So now what can we do? We can talk about statements, like over here on number 1. The first thing we used to do in the congruency statement is we used to write them underneath each other to maintain that order. So now what? We're going to list the angles. So we have angle J, angle K, and angle L. Whoops. These are all going to be identical, so we're going to use the symbol for congruent. Angle J matches up with angle P, angle K matches up with angle M, and angle L matches up with angle N. And again, that's why I wrote the order so I could help myself out there. Now I'm going to turn around and I'm going to list the sides that are in proportion to each other. So I'm just going to write a big statement with 3 proportions. And I'm just going to start with my first triangle and say, okay, this is JK. And who does JK line up with? PM. Then I'm going to move over to KL. KL matches up with MN. And then for the last one, we're going to have JL and PM. And then white's not going to work on a white background. So I'm going to jump back to JL is the same as, or in proportion to, PN. Now, I don't have the exact numerical version, information for all of those angles or these sides, but this is a correct statement, and these are all correct statements. So let's try it again over on the second version over here. Now this is the smaller triangle, and this is the larger triangle. So XYZ is the bigger triangle, RYS is the smaller one. First, I'm going to rewrite my letters so that they're on top of each other. And now I'm going to use the order to line up my angle statements. So of course, angle X is congruent to angle R, and angle Y is going to be congruent to itself. And I can use a single letter because it's out here all by itself. And angle Z from the big triangle is congruent to angle S. All right, and now for my side statements again, I'm just going to set up 3 proportion statements. And I'm going to put equal signs in between them because, again, when I reduce them, these are all the same number. When I reduce them, that's why I use the equal sign. These angles are identical, that's why I use the equal sign. When I make a statement of similarity, I use the similarity symbol. So back to first name side here is going to be from X all the way to Y, and that is very in proportion to R all the way to Y. From Y to Z is the same as from Y to S, and then for my big swooping piece there, I have from X to Z on the big one is in proportion to from R to S on the small one. And there are our side statements and our angle statements. Now the reason it's important to be able to write these statements is that it will help us identify corresponding parts in the very near future, and that near future has arrived. Before we move on, press pause now and complete number 3 on your own. Then pause back in. Now we're ready to do some algebra. So we're going to use similar figures to solve for missing measures. So the first one, it says the figures below have a scale factor of 2 to 3. And generally, if it's from left to right, then we'll assume that the 2 refers to this figure and the 3 refers to this figure. So we'll say 2 is to 3 is the same as 42 is to x. Those are corresponding sides, right? They're both to the left side of their respective figures. So if this is our ratio, then we can put the corresponding sides as an equal proportion, just like we did in our statements, and then we'll use our skill of cross multiplication. So 2x equals 3 times 42. And then the rest is just algebra. 3 times 42 is 126. We'll divide by the 2 on both sides, and we'll get an x of 63. Now, it says to find the value of x. So x looks like it's 63, and we're all set. Again, on number 5, we have this 6 to 5, so I'm assuming that the 6 goes with the x, and the 5 goes with the 28. And now, because this figure is upside down, I still feel that these two sides are the corresponding sides. So we're just going to say 6 is to 5 as the 6 goes with the bigger figure, so does the x. The 5 goes with the smaller figure, so does the 28. And now we set up our cross multiplication. We'll get 5x equals 6 times 28. 6 times 28 is 168, so we'll say 5x is equal to 168. Divide by 5, divide by 5. It's going to be a decimal answer because 8 is the last number. 5's only going to numbers that end in 0 and 5, so no problem. 168 divided by 5 is going to give us 33.6. No big deal. What do they want for a final answer? Find the value of x. So we're all set. X equals 33.6. Let's move on. Now, in this question, they give us a similarity statement to help us figure out what's going on. So I have 2 pieces of information on this triangle and 2 pieces on this one. So because they told me they are similar, it means that their sides are in proportion. Okay, I'm just going to reiterate that. Because the figures are similar, the sides are in proportion. So I just need to make sure that I get the order right. To get the order right, I'm going to use the similarity statements. And this is just like congruency. It's very similar. So what do I know? I know that x has to do with AB. So because x has to do with AB, AB is the same as DE. So x matches up with DE. Then I come down over here. I got 28. 28 is BC. BC matches up with EF. EF is the 20. So I just need to write in a consistent and clear format. I can say x is to 25 as 28 is to 20. Cross multiply, I get 20x is equal to 25 times 28. Now I could also say x is to 28 as 25 is to 20. That's also a very consistent pattern, and I would get 20x and 28 times 25. Notice, same scenario. But I'm going to stick with my initial one. What's key here is to be consistent. So I'm going to get 20x is equal to 700. Divide by 20, divide by 20. And I ran out of space, so I'm just going to put my final answer up here. X is equal to 35, because that's what 700 divided by 20 is. So moving right along, I take a look over here, and I just start matching stuff up. I see x is SR. I go over here, SR is the last 2 letters. So I use my statement to line up the last 2 letters. I guess SR matches up with YZ, which happens to be this side over here. Okay. Next, I see that I have 75 as PS. PS is the first and the last. WZ is the first and the last. There we go. Notice I use the letters first, then I go looking at the picture. I don't try to just match it up by eye. Okay? Don't match it up by eye. Use the similarity statements. Now let's go do the algebra. And again, be consistent in your setup. So I'm going to say x is to 32 from big to small. So 75 is to 40, right? And I'm going from big to small. Cross multiply, 40x is equal to 32 times 75. So that's going to give us 40x is equal to 2400 divided by 40, divided by 40. So x is going to be, well, 4 goes into 24 6 times. So that should be x is equal to 60. And that's going to be our value of x. That's all they want. X equals 60. Done. Of course, a little bit more algebraic, but no more difficult. I take a look at my picture and my organization of my statement. I just see AG is 32. AG is the first two letters. KX is the first two letters. KX, x plus 3 matches up with that. So I could start saying 32 is to x plus 3. I'm working from left to right is equal to, so my top one has to be my left and then my bottom one is my right. Now, just because that's the last two things written, I'm not just going to write it. I'm actually going to do the justice of checking. So 36 is GM. That's the last two letters. XD goes with that. Okay, so it looks like they gave me the right information. So 36 for the left figure is to x plus 6 on the right figure. Now, plus, just want to double check. I got 32 and 36 and x plus 3 and x plus 6. And now I'm going to cross multiply. I'm going to put my parentheses here so I don't forget to distribute. 32 times x plus 6. I write it out first. I'll distribute after. Don't try to bite off more than you could chew in one. And make sure that you properly distribute on both sides. And we're going to just finish up the algebra. So on the left side, I'm going to get 32x plus 192. And on the right side, I'm going to get 36x plus 108. And now I have variables on both sides. I think I'd like to subtract the 32x from both sides. And then, of course, I'm going to subtract the 108 from both sides. I'm just kind of doing this all at once because I'm running out of vertical space. You don't have to do it like that. That cancels out. And 192 minus 108 is going to give me an 84. And 36 minus 32x is going to give me 4x. And the 108's cancel. So now I'm going to divide by 4, and I'm going to get an x. 4 goes into 8 twice, 4 goes into itself once. We got an x value of 21. What did they want me to do for a final answer? Find the value of x. So x equals 21. And we're done. Nice and easy. Get the order straight. Use your similarity statements. Be consistent. Now again, to make sure that we have that corresponding parts, right, we're going to use the similarity statements to identify those corresponding parts. And that's just a little helpful hint for you. So as we move into number 9, and this is going to be our final practice, I'm looking at 25 is TL. TL is my first two letters. CH are my first two letters over here. That's 10. So 25 matches up to 10. As, right, and we're working from left to right, as 4x minus 1, that's LY. That's my last two letters. Last two letters over here are KH. So that's x plus 5. So working from left to right, I'm going to have 4x minus 1 and x plus 5. Being consistent about working from left to right. All the top numbers correspond to this triangle, and all the bottom letters correspond to that triangle. Okay, now let's solve the algebra. Why don't you press pause and work this one out on your own? Don't wait for me. Okay, so press pause, work this one out on your own. I will tell you this, just a little helpful hint. Don't forget to put your parentheses, then cross multiply. And x does come out to be 9, just so you know, but I'll want to see the algebra. Okay, so when you're done, I'll need to see the algebra for this particular answer. Okay. Okay, once you're done with the notes, then feel free to move on to completing more practice with similar figures 1 through 10. That's essentially just the next page. If you feel you want to ask questions first, then feel free to ask me, right? If not, just continue on. And once you've completed the notes and the practice, then stop and check that work in with me for completion credit. The homework will be posted, but first you need to check in with me. Okay? Good job so far. I'm proud of your efforts.